Today I'll be showing you how to assemble a cart reader from the ground up. This tool opens many possibilities by enabling you to dump retro games that you physically own to an SD card along with your save game progress. This comes in especially handy for games losing their battery life, because once it's dead, your progress is gone forever. By dumping your cartridges, you can also transfer them to all sorts of modified consoles or even use them on a basic PC for emulation purposes, with progress you made over the years in HD even. You can also patch games you physically own with modded files for all sorts of things made by the community. With this tool you could even duplicate your existing physical copy, patch it with a ROM hack, and write it back to, say, a bootleg cart you bought off of eBay and play it on actual hardware. There will be links in the description for where you can buy all the parts and components you'll need. I've physically cataloged these throughout the videos so you know exactly what goes where, so let's get started. The first thing we're going to want to do is begin populating the board with surface mount components. That way everything basically stays flat until we absolutely have to move on to the more uneven portions that make things a little more uncomfortable or even inaccessible at times. For this I like to prepare the area with as little solder as possible to ensure you don't end up with a sort of floating component rather than one that adheres to the surface. For best results I recommend soldering one pad at a time. Tack it down on a single side using a pair of tweezers to keep it in place, and continue on with the other side once you feel it's as flat as you're going to make it. I was somewhat rushed into making this video, so as you can see I didn't apply these conditions to my workflow. I also like to keep a no-clean flux pen handy. It's not absolutely necessary, but it can be helpful in some certain areas, such as with the cartridge slot for the Game Boy connector, to prevent solder bridges from occurring. What this does is create a sort of barrier that keeps the solder in place and directs it towards the copper pads. I'm not going to go into full-fledged science class about molecules and different kinds of metals and everything. Just know that in some instances you won't regret having one around. Although most components aren't specifically required, the 1K ohm resistor is one of the more vital according to functionality in my opinion. This will allow you to connect a Nintendo 64 controller to test the buttons and dead zone of an analog stick, as well as read memory packs and back them up. While this doesn't have an extensive directory containing pages of single saves where you pick and choose what game saves you'd like to back up, this will copy a single file which you can then transfer to a PC and dissect there as you'd like. You can later transfer your edited memory pack back to the SD card and upload it back onto a physical memory pack similar to the way a DEX drive works. Memory packs were utilized by a smaller amount of games on the Nintendo 64. Some popular titles did require one, such as Doom 64, the Rampage series, San Francisco Rush, Tony Hawk's Pro Skater, Rayman 2, Killer Instinct Gold, and even Diddy Kong Racing for save ghost data. If you'd like to cut down on costs, you don't specifically need to add the 10k ohm resistors, which would ultimately eliminate the need to solder the push buttons and OLED display, as well as a few other points such as the battery compartment and OLED jumpers. Of course, in using this method, you'll have to alter the code slightly and lose all portable functionality, which could reduce the price even further by eliminating the need for a battery or battery compartment in the first place. The way I see it though is, if you plan to make one of these, why not do everything all at once? That way, in the future, you won't have to go through the trouble of soldering around everything else. And if maybe suddenly your cart reader will no longer connect via serial for some odd mysterious reason, it's always good to have an alternative method regardless. The voltage regulator is a vital component in this project, which will allow us to switch between 5 volts and 3.3 volts. We'll later be adding a switch that will allow us to change these voltages depending on the cartridge we're trying to read or write. The switch configuration can be confusing if you allow it to be, so I'll try to simplify on this as best I can. Basically, if you're reading or writing a cartridge 16-bit or below, you're going to want to set this first switch to 5 volts. This would include Game Boy, Super Nintendo, and Sega Genesis. Remember that the clock switches here are specifically for Super Nintendo, so we'll want to flip both of these switches while reading or writing to these cartridges. Now, the Game Boy Advance is a bit of a wild card. It is in fact a 32-bit console, although deceiving in a way that it may seem like just a portable Super Nintendo. So in this case, I sometimes have to remind myself that 90s consoles used more power, so the switch rightfully stays at 3 volts. Now, the Nintendo 64 is in fact a 90s console, but it is also 64 bits, which brings us back to the first rule. 16-bit or below gets 5 volts, so in this case it gets 3. Moving on to the second switch now, consider this EEP switch exclusively for N64 cartridges and memory packs. And of course the last two switches relate to the Super Nintendo, so we'll leave those as they are. You may initially find the tantalum capacitor intimidating, or maybe even overlook the fact entirely that its contacts come from underneath, so you won't be able to simply pile solder up the side of it to have it maintain a proper connection. This is where a flux pen can especially come in handy in conjunction with a light pool of solder prior to installation. The PicKit programmer can be somewhat of a hassle in a few different ways. First of all, you'll notice that the cable comes with all wires aligned in a single connector that you have to manually break apart and connect to the pins on a separately purchased SOIC adapter socket to place your PIC chip in. This chip needs to be orientated exactly as shown on screen in order to be programmed successfully. I was going to elaborate on this part extensively, but it seems they've discontinued the product, possibly due to the massive amount of counterfeit products out there, so I'll touch on this briefly. Under Tools, check Communication. Make sure the correct chip value comes up, PIC12F629, and make sure your OSCAL value matches the last line of the code. I stress to write this down as well in case anything goes wrong. If you lose this value, your chip will be rendered useless. Next, load the hex file and check that the last line of the code is the same as the OSCAL value. If it is, simply hit write. If it doesn't work, try it again. If that worked, hit verify. This button may not work though. The program is screwy, so if you're unsure, close it and reopen it and read it again. We just want to make sure that this chip has been written to properly before soldering it in. It's a mid-range standard chip if you're unsure which device family it should reside under, and don't mess with the VDD settings. If you're running into problems, it's probably due to a knockoff device or the program itself. Just keep trying. There are two known variants depending on the screen you ended up receiving. Check the letters above your OLED screen and follow the provided diagram in order to solder the jumpers properly. This part is easy enough without any further explanation, as you simply bridge two solder points in the location shown. PIC12F629 chip is possibly the most interesting component in this project due to the fact that both the Super Nintendo and PlayStation security measures can be exploited with it when programmed with the correct hex files. Of course, this wasn't always the case. The original PlayStation mod chip hex files were actually written to different chips, which can only be written to once, and since then this code has been altered for use with these chips, which has become more common due to accessibility, cost efficiency, and the ability to reuse them in other projects once rewritten. Super Nintendo Virtual Pirates also used different chips in the beginning, but since the original security measures have been rewritten from the ground up and released as open source to the community, they often thrive here as well. Within this project, this only pertains to SA1 titles, and if you really don't see yourself dumping or editing European or Japanese imports, there are only a select few North American releases that you may have trouble with if you plan on skipping out on adding this chip. As shown in the list but pointed out more specifically, these are Kirby Superstar, Kirby's Dream Land 3, PGA European Tour, PGA Tour 96, Power Rangers Zeo Battle Racers, and Super Mario RPG. Throughout this whole process, my work has admittedly been a bit sloppy. While working through this particular build, I was streaming the process live, so rather than focus on the quality of my work, I overlooked many of the mistakes I would have further corrected had I thought things out a little differently before beginning. For starters, the soldering tip I used was already attached to the iron, so once I had it heated up and realized the tip was much larger than the one I should have been using, I didn't want to hold up the process any longer than I had to. Secondly, out of a brief frustration habit, I decided to try a method called drag soldering to unbridge a connection from the 2 points shown. I could have done this successfully had I used a blade tip, although this could have been a major mistake if I hadn't had a desoldering braid handy, so I do stress to have at least a little of this in your collection somewhere as well. I also want to mention that further into my stream I did end up touching up these points while working on other components in the general area, so if you feel that you could have done a better job somewhere, take your own advice and follow your intuition rather than pay for it later. The Game Boy Advance cartridge slot has some of the most challenging points you'll come across throughout this entire project. This is where the flux pen can drastically improve your success rate. My best advice is to follow each point at a steady pace. As always, don't feed too much solder into these points and keep an eye out for solder bridges every step of the way. Preparing the Arduino first begins with removing the voltage regulator so we can bypass this one with the one we attached to the board we installed earlier. This component is no longer needed and can be discarded or saved for future projects down the line. At this point I should have removed the transistor from the Arduino as well. I could have simply added the clip here where I later removed it, but I had more footage involving the Arduino so I didn't want to confuse people as to why it may have reappeared. So here we're adding a ground wire that will later be soldering directly to the main board. We'll want to make sure to leave a little slack here, around 3 to 4 inches, so we'll be able to pull the Arduino from the board without ripping it off. We'll also want to add a power wire to the capacitor of the same length for the same reason as previously stated. So now we'll line the Arduino with male pin headers all the way around, which will later be soldered directly to the board. These can be easily measured up to the amount of pins we'll need and snapped off accordingly as shown. Next we'll be adding the OLED screen into place. Your screen may come with pins already attached with the plastic spacer on the reverse side of where it's most inconvenient and maybe even bent pins. You'll want to push these pins through the reverse side and cut away at the spacer. What we want to worry about at this point is keeping the screen flush with the board. On the other side of the screen, push this down until it's as close as we can make it. This is where we want to make sure to hold it into place. As you can see, the first solder point seems like a mistake on my part, but I was merely covering my tracks from a previous mishap while initially removing one of the pins. What happened was one of the pads lifted while I was pulling it through, so I wanted to make sure it was getting continuity. I used a scratch pen in order to fix up my work by bridging the connection. If you happen to do it correctly, you won't have to add such a grotesque blob as I had. When using a flux pen, always clean up your work with some isopropyl alcohol of the highest content you can find. Flux is corrosive and will deteriorate your board over time if left untreated. I recommend using a toothbrush so you can really get into those connections. Even if you accidentally drench your board in alcohol, it dries fast, but do try to use it in moderation. As marked on the board, we'll want to add the RGB LED into place, starting with the side that has one shorter leg, then the longer leg, followed by two other short legs to the right. Here's apparently where my camera went dead before I could catch it, so footage of me soldering it into place has disappeared forever. Here we want to fit it in with the spacer as a reference while we keep a mental note of where the Nintendo 64 slot pins will be coming through. We'll want to do this now and snip the pins on the other side flush with the board, as they will be inaccessible once the slot is in place. The Nintendo 64 Slot Connector is pretty self-explanatory, but I'll add that you may want to tack it down on opposite sides before you begin to keep the slot level. Then begin soldering the remaining pins. You may run into a little trouble where the LED is soldered. I found the best method here is to stand the LED back up straight, solder around it, then bend it back into place with a pair of pliers to ensure it has enough leverage as to not snap off the legs. Bend this over like a dirty whore. The microSD module came a little different in my later shipments than the previous ones. First of all, it has bent pins you'll want to try to straighten out as best you can, then cut them down with a pair of side cutters about 2mm to fit the female pin header we'll be soldering into the board next. You'll probably also notice that while trying to fit this module into place, it'll seem a bit longer than what it should be. Here you'll want to use a rotary tool to remove around 2mm of the board by cutting along a white line. You'll find there are no markings where the female pin header should go, but near where this is will be another connection that has 2 rows of 8 holes rather than 6. Directly underneath these 2 rows is where we will find a spot with 6 holes for this pin header. I chose next to add the single pole double throw switches simply to get them out of the way, but you could choose to do this earlier or later on since there's a very low level of obstruction by any of the other components throughout this entire project. On the opposite end of the board, in line with the SD card slot now, we'll be adding the Clockgenerator female pin header, which has 7 pins and is easier to locate than the last. A very simple procedure with very open points as long as you do it during this last opportunity to do so before things get a little more complicated. Otherwise you'll be bombarded by pins from the Sega cartridge slot as well as pins from the Arduino. Depending on the brand you're receiving, if you get the non-Foxconn Sega Slot Connector, this will come with tabs on both sides that need removed prior to installation. You can remove these easily and cleanly with a simple pair of side cutters. From here we can just solder it into place like any other, pushing down on the top side to ensure it's not at a tilt while soldering it in. In all actuality, the next best step would have been to solder the first row of Arduino pins before moving on to the next cartridge slot. Keep this in mind while working on your own. The making of this video was partially as a reference point to myself in the order of which I could work more efficiently and calculated in the future production by highlighting these techniques and utilizing the best course of action down the line. Installing the Arduino is pretty straightforward. Simply line up the pins we added earlier, press them firmly into place, and solder each pin one by one. After this process, we can remove the board once again and continue on with the rest of our build. The Super Nintendo slot requires a 3D printed spacer in order to stay aligned with the other cartridge slots. You can find the STL file as well as all the other 3D printed parts on Sandy's GitHub page located in the description of this video. I suggest having everything printed beforehand, or at least most of the major parts obviously, so you don't have to come to a complete standstill during the process. The optional barrel capacitor will help with consistency while reading Sega Genesis and Super Nintendo cartridges. However, it will make things a little more sloppy while wiring the Arduino or battery compartment power and ground, in which reliability is always worth the sacrifice over aesthetics. With the battery module, we'll be soldering 4 different leads, which will remove the need for the micro USB as well as the larger one, and also cancel out the functionality of the switch altogether. It's your choice to remove these components or leave them intact here, although you may find the standard female USB poses a problem with the outer shell casing while attempting to fit everything together. Either way, this has no bearing on the final product. Having made it to this point, I trust there's no reason to mention much here. Simply snap off 7 pins and solder them to the clock generator. Just be aware of the orientation of the board when you solder them in. With my first build, it actually came pre-soldered with the pins facing the wrong way, so it took a little finagling to reverse them. If they did happen to be soldered incorrectly, it would not short anything out, it would just cause the device not to power on until the clock generator was removed. Rather than redundantly explain step-by-step how to install a plug-and-play device using a prepackaged zip file supplied by Sony over at GitHub, I've decided to simply show this on screen the way it should be done. Be sure to turn the power on to your cart reader and you should have no trouble at all. If you share a PC with a 3D printer, you may have to unplug it while uploading the code to your device due to complications with the COM port assignment. Also, don't forget to add the file supplied in the SD folder of that same zip file to the root of a FAT32 formatted SD card. I found that 8 to 16 gigabytes is more than enough and actually had trouble with higher grade 32 gig cards. And with that, the project is practically done. However, there are a few more things we need to finish up on in order to ensure this device performs exactly as intended. Beginning with the transistor I forgot about earlier. With this in place, the battery lights don't display properly, which is possible the battery may not be getting a charge or maybe even malfunction and potentially explode if it isn't removed. Of course, I'm not sure of the validity of that last statement, but when it comes to batteries or electricity in general, it's best not to take risks you're uncertain of. This power plug is no longer functional and can optionally be removed as well. It no longer serves a purpose and it's potentially an invitation to destruction if something were to be plugged into it in its current state, so if you have the tools and you've already been this patient, you might as well remove it also.
Okay, there we go. Seal is not. Wow, that's way too much.
So now we'll be adding the leads for both the controller and memory pack. Provided you've installed all the needed surface mount components I discussed while adding them, it's a 3-wire installation. You could simplify this by cutting the extension cable and soldering it directly to the pads. I've chosen to test out a quick disconnect method this time around, so if you'd rather skip all this, here's a quick diagram, solder your wires, and hey, you've made it. I appreciate you accompanying me on this vast journey of unpleasantness, and you've been a wonderful companion. Now get going, you scamp. Alright, so rather than leave everybody in the dark right at the end, I 3D printed these dust covers, so when I'm not using whichever slot, then they will not get dust in them, obviously. There's one for the Game Boy Advance. I'm going to set these off to the side and get back to the internals again. Now, this is not completely flush. I have managed to cut a sloppy hole in the bottom to make the battery fit. So what I'm going to do here is solder these wires up so I can use one of these extension cables for a Nintendo 64 controller. Which I'll be using this end, because this would be plugging into the N64, and I want the controller to plug into that. So what I want to do is cut this off a little short. I may actually make an end that will fit back into this in case someone would ever want to use it. I don't know. It's not important. What is important is cutting it off and splicing these wires together. So let's focus on that. Okay, so all 3 wires are exposed. I'm going to move this junk out of the way here too. So much crap. But yeah, basically just strip these wires, get my soldering iron on. Strip these out. Length isn't a particular interest right now, and we'll want to slip these tube covers. Where are they? We'll want to slip these heat shrink tubes on them. See if this will work. Yeah, I can probably get away with using this one. But I'm gonna split this off into 3 for all 3 wires. And then I will put one of these over it to cover the overall thing. Twist these wires up. And I have a little connector. Whatever I did with it, there it is. Let's see, I cut 3 pins off of this female pin header. And I also had a male pin header, which I cut 3 pins off of. So this will fit right in ya, like that. And I plan to have it go on the inside of this board, right above the USB port. Glue it down with hot glue. You don't want to put hot glue on a 3D printed case because it will melt right through, at least with my industrial one it does. So that's what I'm going to do. The idea here, I want this side to be attached to the board. So I'm going to solder these wires. And they won't be moving because the hot glue will hold it in place. So I won't have to worry about that side. But I do want to cover this side with heat shrink tubing. And have just enough to fit on the end of this so I can pull it apart. So that should take maybe about this much. Slide the sleeve over first. Slide it all the way down. Twist these up the best I can. Slide a sleeve over each one individually. Now, the male pin header. I'm going to bring it up to as far as I can. Yeah, that's about the best I can get it, which made it pointless. So but that will cause this other outside heat shrink tube to stick a little bit better than it would have initially. So we'll go with that. Bring this up over it. And that looks good, I think. So on to the next phase. I'm going to have to take this all out. I actually need to, yeah, this is where it needs to sit, right above there. So I am going to have to remove this Arduino, keeping note of where my cords are coming out. I'm going to take this off so I don't break it, and this too. And while I'm in here, I'm going to put a little dab of hot glue right here so these in the future will not be removed. Oh my god. Okay. I'm going to remove this battery so it doesn't explode or something. Just in case I short something out. And about here is where I will stick this down. So let me fire up my soldering iron, try to get these wires soldered real quick. That way I don't have to keep reheating my glue gun that I already have heating, which I shouldn't have, but trying to get this done quickly, which is always a bad idea. Always twist your wires so you don't have little strands everywhere. And always clean your tip. That's what she said. So get a little bit of solder here. A little too much. And I just want this to stick to the wire so I will be able to control it. Now remember, it's going to be red, green, and then black. And internally, I'm going to have it go up through these, so it will reach a lot simpler. And now if I can hold this down, I will be in good shape. I just want to generally get these touching. Glue it down, and then I will worry about how well it's sticking. Fix up my solder points at the end. So that's sticking. dab down here, which I gotta be extremely careful because this thing just shoots glue right out. That is good. And now I have to think logically, which way is red gonna be? Red, I want to be on the left. So I'm gonna flip this and stick it right here. That too is what she said. So just a dab. And stick her on down. Okay, I can turn off my hot glue gun. And fix up these solder joints. So I will reheat this, remove it, and reseat it. These ones seem fine for now. And this is just a prototype, so that's how I'm gonna go with it. So now I gotta put this all back together. I wanna make sure these go over this. Use my tweezers so you can see better. There. If I have hot glue, I will stick that down a little bit. A little too much. Get this. Okay, so there we have it. Good, good. And as you can see, it's right inside there. So I will be able to connect this inside here and use this to read controller packs. I'll test that out now. I don't have screws for this case, so I'm gonna go ahead and put these dust covers on just to keep everything inside. Because I won't be using it anyway. Here I've got my N64 controller, and my N64 plug. I will go to Nintendo 64 on the cart reader. Go to controller, test controller. There we go. So hold the stick up and press A, up right, right, down right, down, down left, left, up left. I can also read my controller pack, which is right here, saved. So there we have it. Awesome.